Hello everyone. In the last video we will discuss in the last video of this topic we will discuss about the basics of sequestering agents, its role, its functions, and some generally commonly used sequestering agents. Now in this video we will discuss about its evaluations and its analysis. The strength and the function, the strength and the purity and the importance of the sequestering agent can be analyzed by analytical method as well as by the performance methods. In analytical method, we will analyze the sequestering agent by using different method, maybe titration or like etc. And in the performance by the performance evaluation method, we will use the sequestering agents in the actual wet processing bath, and then compare the properties of the output product, means the treated fabric of this bath with the treated fabric of the bath in absence of sequestering agent or in presence of sequestering agent, and then compare how sequestering agent will counteract the hardness and what effect will be produced, what effect will be generated by using sequestering agent in bath. So very first we will discuss about analytical method. In the analytical method, very first we will discuss about the procedure. We will discuss about the EDTA analysis. So for EDTA analysis, 10 gram of samples are weighted and mixed with 100 ml of distilled water in the distilled water in 200 ml our 200 ml flask, and to this 5 ml of ammonium oxalate indicator of 6% are added, and then mix the well, and then titrate above content against 0.5 molar standard calcium chloride solutions after adjusting the pH between 11 to 12 by using 50% NaOH. As all of you know, if the amount of NaOH will be added according to this pH. The pH is maintained between 11 and 12 during the titrations, and the appearance of slightly turbid is taken as end point. So as you add the calcium chloride solution in the above content, means the sample and the distilled water, and ammonium oxalate indicator, then the solution gradually solutions become slightly turbid. So you just carefully see the users carefully wait. The appearance of the slight turbidity is taken as end point, and the chelation values as calculated by below formulas. So very first you should you should carefully take the endpoints where titration should be stopped. We can say the titration is completed. That is, the solutions turns in turbids. So you should do titration up to the solution turns to slightly turbid, and then noted the volume of calcium chloride is consumed in this titration. By this way we can calculate the chelation value, that is ml of calcium carbonate solution into 50 divided by grams of sample, that is a chelation value. Chelation value means the capacity of the any sequestering agent to form the complex with the water hardness. Now by using chelation value you can calculate the percentage purity of these sequestering agents. So the percentage purity of the EDTA can be determined by very first determining the chelation value by this methods, by this formula. In this formula, the first is ml of calcium chloride solution, that is the consumption of the calcium chloride. It can be measured by burette reading, because it can be measured by burette reading. In burette we added the calcium chloride, and in conical flask we added the sample and ammonium oxalate. Ammonium oxalate is titrated against the calcium chloride. So by this titration we note the ml of calcium chloride solution consumed in this titration, it multiplied by 50 divided by gram of sample, that is chelation value. After getting the chelation value, we can calculate the percentage purity. Chelation value into molecular weight divided by 1000, that is percentage purity. So by this method we can estimate the percentage purity and strength of the any type of sequestering agent via analytical methods. So dear all, in this video, now we will stop the video because this topic is our. We had discussed about the sequestering agent. In the next video of this online lecture series, we will discuss about evaluation. We will discuss about evaluation of the dye stuff. Thank you very much.